Okay, let's look at the first one. Now, these are the same equations we had completed before. So we said that when we traded partners, we got 2 ammonium chloride, that was aqueous, and sodium sulfide, which is also aqueous. So that was the old stuff. We did that previously. Now, the new stuff, when I break this into the ionic equation, anything that is a soluble, strong electrolyte breaks apart. So this breaks apart and we get 2 ammonium ions, because there's a 2 here, they are aqueous, plus a sulfide ion, aqueous, plus, oh, I didn't have this balanced, there we go, plus 2 sodium ions, aqueous, plus 2 chloride ions, aqueous. That yields 2 ammonium ions, aqueous, plus 2 chloride ions, aqueous, plus 2 sodium ions, aqueous, plus a sulfide ion, aqueous. So all of these things were strong electrolytes that were soluble. So when you look at this, what cancels out? Everything. So we have no real chemistry, no reaction. So sometimes you dump all these things together and you don't get any chemistry going on. Okay, let's look at the next one. Ammonium carbonate and sodium hydroxide. We need 2 here. We make sodium carbonate plus ammonium hydroxide, which becomes water and ammonia gas. To balance this, I need 2 ammonias, 2 waters, and 2 sodium hydroxide. Sodium carbonate is aqueous. So now when I break these down, this is a soluble, strong electrolyte, so I get 2 NH4 plus aqueous, plus CO3 2 minus aqueous, plus 2 sodiums, you keep those coefficients in there, plus 2 hydroxides, yields. Sodium carbonate is soluble, so it breaks apart. 2 sodiums, which are aqueous, plus carbonate, aqueous, plus 2 waters, water's a liquid, plus 2 ammonia gas. So here we have real chemistry. We made a weak electrolyte and we made a gas. So when I look at what breaks down, okay, everything, and then what appears on both sides, 2 sodiums and a carbonate. So what's left is 2 ammonium plus 2 hydroxides. Both of these are aqueous. You do have to be really careful to write those subscripts in this chapter. And it's a nuisance. And often you'll see me have to back up and put them in there because you just kind of don't think about them. But they belong in there. And on the test, if they're not in there, they're not correct. John?
Would I be wrong since there's 2 NH4s? Would I be wrong to write instead of like a 2 plus charge for the total charge? Or?
That would be wrong because it's not one thing with a 2 plus charge. It's 2 things with a plus 1 charge each. So you don't write a 2 plus up there. But that's a good question because that is something I've seen students do by mistake. So now you look at this and you say, well, there's the real chemistry. I have ammonium ions from any source plus hydroxide ions. I make water and ammonia gas. Okay, let's look at the next one. Ammonium carbonate, again, this reacts with iron 2 hydroxide, and we get ammonium hydroxide, which gives us ammonia plus water, and we get iron carbonate solid, iron 2 carbonate. So that's a solid, water's a liquid, ammonia is a gas. We have to make sure the equation is balanced, so I get 2 ammonia and 2 waters. Now, when I look at this one, to break it into the ionic equation, I get 2 ammoniums, NH4 plus, aqueous, plus my carbonate, aqueous. Now, this is a solid, so I don't break it apart. It stays solid because solids are sitting in the beaker. They're not floating around there. And I get 2 ammonia gas plus 2 water, liquid, plus iron carbonate solid, iron 2 carbonate. Now, I got a triple header here. I got a gas, a weak electrolyte, and a solid. I had a lot of chemistry going on there. What can be canceled out from both sides? Nothing. So this is the net ionic also. So the ionic and the net ionic are the same. Okay, and let's look at the last one. Iron 2 sulfide solid plus 2 hydrogen plus HCl. We get iron 2 chloride, aqueous, plus hydrogen sulfide gas. So here, the HCl breaks apart, 2H plus aqueous, plus 2Cl minus aqueous, yields iron 2 aqueous, plus 2 chlorides aqueous, plus hydrogen sulfide gas. Now on this one, what can I cancel? Can I cancel the Fe? It's not in the same form on both sides, so no. Just the chloride ion. So I get iron sulfide solid plus 2 hydrogen ions yields iron 2 ion plus hydrogen sulfide gas. You can see how it takes a lot of practice to become proficient at this.